Imagine you are driving in 1935. The highway ahead looks endless, and with so few cars, you glide without thinking. Then more vehicles appear. You ease off the gas. The open road tightens until everyone moves like beads on a string. One engineer looked at that shift and claimed it could be described by a single simple curve. This is how Bruce Greenshields turned the feel of traffic into math. Picture a young engineer on a bridge with a camera, counting vehicles and estimating their speeds from frame to frame. The country is building roads fast, but there is no agreed way to connect three basics: how fast cars go, how many occupy a mile of roadway, and how many pass a point each minute. Greenshields offered a bold idea. As crowding on a road increases, speed falls in a straight line. Start with free-flow speed when the road is empty, end at zero at a jam, and connect the 2 points. From that single line, everything else follows. If speed drops linearly while density rises, then flow, which is speed times density, forms a smooth hump. At first, adding cars helps. More vehicles at nearly free-flow speed means more throughput. Then the curve crests. Add a few more, speeds sag, and the road carries fewer vehicles per minute. There is a sweet spot where the road moves the most cars, and beyond it, the whole system strains. In daily life, you feel this without equations. At dawn, the road is quiet and you move fast, but you are mostly alone. So total flow is modest. As the city wakes, lanes fill and the system hums. Push past that point and the mood changes. Small hesitations ripple backward. A tap on the brake becomes a wave. The power of the curve was not just elegance. It gave engineers a common language for capacity. With a line and a hump, you could estimate how many vehicles a facility could carry, compare designs, and build simple simulations. It was a first shared framework linking speed, density, and flow. But simplicity comes with a price. The original study drew on a small set of observations. Real drivers are not identical, and real roads are not frictionless pipes. Some corridors lose speed gently as they fill. Researchers proposed alternatives that bend differently near capacity and behave better at high densities. Weather erases capacity, and heavy vehicles change effective spacing. The tidy line is a sketch across a noisy cloud. Even so, the legacy is durable. Classes still start with Greenshields because it teaches the relationships cleanly. Pick 2 anchors, free flow speed and jam density, draw the line, multiply by density to get flow, and find the crest for capacity. From there, you introduce the messiness of reality and ask how far each road deviates from the ideal. When you are next inching forward on a packed freeway, look around. The space between bumpers, the speed on your dashboard, and the waves of cars passing a signpost up ahead are connected. Nearly a century ago, someone sketched those connections with a simple line and a hump. We have spent decades refining the picture, but the original insight still whispers through the noise. The road is a curve, and we are all moving along it together.